Welcome to the last part of chapter 13.1. I decided to hold these problems off. I call them beyond the basics only because there's some formula manipulation that you need to do. So let's take a look at this first question. Jim takes a 12% simple interest loan today that will be repaid in 3 months from now with a payoff amount of $9,000. What amount is Jim borrowing? So this is a little bit different because the previous questions were saying this is the amount we're borrowing. What are we going to have to pay back in the end? This is the amount we're borrowing. What is the interest that's going to accrue? Right? Those were the questions. This is different. Here they're giving us the end amount, the payoff amount of 9,000. And so what the 9,000 is in our formula, sorry, let me make it a pen. The 9,000 is our A, not the P. They're actually looking for the P. They want us to find how much Jim's borrowing. Sometimes P is called the present value. P is the principal amount, the present value. We want to find P, how much he's borrowing. Well, we're going to use the same formula. Now, remember, it's simple interest, so they do bounce back and forth. So the simple interest formula where we have the accumulated amount or the final amount is A is equal to P times 1 plus RT. And in this case, we want to find P. So using our algebra skills, we can solve for P by dividing by 1 plus RT. Put that in parentheses. Gone, gone. So one way to do this, and they demonstrate this in the book, and you could come to the exam with this written down, that the present value, if you need to solve for it, or the borrowed amount, is A over 1 plus RT for simple interest. So in our case, A was 9,000. 1's a stagnant number. The rate was 12%, so we're going to do a 0.12. And we're going to multiply that by the number of years, but it's 3 months. So I'm going to put 3/12 in there. And so now we're going to plug this into our calculators. Need to go run and grab a calculator. I didn't realize I didn't bring one with me. And so we're going to take the 9,000 and plug that in. And then in parentheses, we just plug it in directly like you see it. You want to do as little translating as possible. So 9,000 divided by, and then I would use an open parenthesis, 1 plus 0.12 times 3 divided by 12. So 1 times, not 1 times, 1 plus 0.12 times 3 divided by 12, close that parenthesis, and then hit equals. And we get an amount, that's the borrowed amount. So the borrowed amount is going to seem a little bit weird because we had a beautiful payoff amount of 9,000. And so it's $8,737.86 if we round it to the nearest cent. That's how you find the present value. And again, there's examples worked in the book. You could do a help me solve this on one of the questions that comes up. But we're hoping that you'll be able to look at something like this and say, I can recreate that. So good formulas to write down is this one right here. They show that in the middle of page 733 in the text. Right? So everything that we're doing is, as you know, represented in the text as well. So here we got, they want to know the present value. So again, they want to know what P is. For the future amount of 19,000, so 19,000 in the end, we have 2% compounded quarterly for 5.5 years. Okay, so it's compounded quarterly, so we're going to have to go to the later formula, right? We remember that the accumulated amount formula looked like this. It was pretty involved, right? 1 plus R over N to the NT. Well, if we solve for P, we would be doing the exact same thing that we did in earlier. And we would divide both sides by 1 plus R over N to the NT. So the present value, let me make this wider. The present value then would be A divided by 1 plus R over N to the NT. we should be able to plug that into our calculator. We'll be really careful as we do so. And so let's take a look at what we have. In our problem, our accumulated amount, what we want to accumulate, is $19,000. So let's suppose we want to save $19,000 and we know it's going to be 2% compounded quarterly and we're going to save it for 5.5 years. How much do we need to set aside right now could be the question. So this is 1 plus R was given as 2%. Be careful not to write it as 20%. 2% divided by 4, because it's going to be compounded 4 times a year. That's 4 times a year for 5.5 years. Okay. Now we could simplify this a little bit. I think that's going to be a little bit difficult to tell our calculator what to do here. So maybe I would do something like, well, they're not modeling that in the book. They're just plugging it in. So let's see if we can just plug it in. 19,000 divided by, we'll do this together, 19, 1, 2, 3 zeros, divided by, and then in parentheses, we want to do 1 plus 0.02 divided by 4, close the parentheses, and we're going to raise that 2, and we should do that exponent before it does the division, so I think we'll be okay. Raise it 2, that's my symbol. You may have a y to the x. You make sure you use an open parenthesis since we haven't figured out the product. 4 times 5.5. And we'll close that. And we equals, and we find out that what we need right now for the present value would be $17,025.51. That would be the present value of the account that's going to grow over the next 5.5 years at a 2% rate that's compounded quarterly. Pretty cool. So here's an application, right? A pretty decent application. Whoops. Let me undo maybe. Okay, so here's our application. Sorry, somehow it went away. Tammy wants to have some additional money in her retirement. If she plans to retire in 25 years, find the lump sum that she must deposit today so that $200,000 is available for her at retirement. If the interest rate is 8%, again compounded quarterly. So where did I find this? I found this straight in the homework that you're being assigned, right? So all these problems I grabbed from the homework so that it would be totally related to what you're doing in there, just like I have in the past videos. Well, we know that formula. It's right above. P is equal to A all over 1 plus R over N to the NT, because what they're asking is, what do we have to put aside today? What's the present value that I need in order to accumulate $200,000? So she wants $200,000, and their interest rate that she's expecting is 8% compounded quarterly, and then that's going to happen over 25 years. Okay, right? And so we're just plugging everything in the way that we see it in that formula. Everything's given in years. So let's see what she needs. Let's take the 200,000. Make sure to get all the appropriate zeros. Divide by, open parentheses, 1 plus 0.08 divided by 4. Close those parentheses. Raise to the open parentheses 4 times 25. Or you could just raise it to the 100 if you know that 4 times 25 is 100. And it equals, and this is what she has to save. She has to put in the account right now $27,606.59. So if she saved $27,606 right now and just put it aside, not even touched it, in 25 years, right, it's got a lot of time to grow, it'll grow to $200,000. Let's check that. Okay, let's check it by saying, okay, what's the accumulated amount if we take the present amount, $27,606.59, times 1 plus the interest rate of 8%, that's compounded quarterly, for 25 years. So if we check our answer, right, you have extra time on your test. 27606.59 was our answer. Here is the check, right? This is doing nothing more than seeing if we get 200,000 times 1 plus 0.08 divided by 4 to the 4 times 25, and we do. The accumulated amount is, in my calculator, is 1,99999. 1, 2, 3, 4, 5, 5 nines, 0.97. 0.51 or 0.98. So you can see, it's because we rounded off this 27,000 figure. You can see that we've accumulated really $200,000. You're 2 cents shy of it because of the rounding that took place. So if she saved 27,607, she'd be a little bit over 200,000. But that's what she'd have to set aside today. So it seems kind of nice. I mean, I don't know many of us that have an extra 27,606 to just set aside. But if you did, it would grow to 200,000 if you could count on that 8% rate happening on average over those 25 years, compounded quarterly. So just some further applications that are done in the homework. So that's what we're looking at in this 13.1 section.